The section is 3.1, the derivative in the tangent line problem. So let's start with the tangent line problem. Recall a secant line is a line that passes through the 2 points on the graph of functions, such as this one's over here, through the point PQs on the graph, and this PQ is called a secant line. Now, when it's the tangent line, I mean the line that touches the graph at a point. On the points, the points P here is where it touches, called the tangent point. Okay. Now the graph might be, the line might intersect the graph at other points on the graph, which is fine, but it touches the graph at P. So this is called the tangent line. So the question here is, how do we find the equation of the tangent lines at a given point P? Right, so here's what we're going to do. If we're going to find the equation of tangent lines, we will start with the secant line. So let's say this green line, okay, go through the graph at P and Q. This is secant line. So at P is at x1, Q is at x2. The corresponding y is f of x1 and f of x2. Now, how do we find the slope of the secant line? Well, slope of the secant line is easy to find because we have the formula y2 minus y1 over x2 minus x1. So once we use the formula to find the slope of the secant line, right? So what we're going to do is we will move the Q a bit closer, right? So I can still find the slope of this secant line. And then move it a bit closer, and I can find the slope of this secant line. So as Q getting closer and closer to P, then notice that the slope of the same secant PQ will be approaching the slope of the tangent line that we want to find. So as we're approaching, so you see that there's a limit process going on. So that is the idea. Now let's start with the technical. Let's say we have the formula, right? So we start with the slope of the secant line. Slope of secant is y2 minus y1 over x2 minus x1. And notice that y2 in this case is f of x2, right? So the corresponding y here is f of x2, and that is f of x1. Okay, so you can see the formula: f of x2 minus f of x1 over x2 minus x1. Now, to make things we want to change the notation a bit to help understand. One point is fixed. Notice that in the previous slide, the P is fixed, the Q is moving. So at x1, let me call this as A. Okay, so just a fixed constant. In Q, the x coordinate of Q varies. So we're going to let x1 be A, be an arbitrary constant, and x2 be x. This is x, it's varying. Okay, so if you put it in, so you see here's is A, now it's f of A. If this is x, this is f of x. And now you have a similar formula, f of x minus f of A over x minus A. Then we're going to find the slope of the tangent line. Well, to determine the slope of the tangent line, we let x approach A, right? So recall, we want the Q is getting closer and closer to P, and therefore the x coordinate of Q is getting closer and closer to A. So that is x approach A. In terms of limits, we are finding the slope of the secant line at x approach A. Formally, slope of the tangent will equal slope of of secant, actually the limit of the slope of secant when x approach a. And again, slope of secant line from the previous slide is f of x minus f of a over x minus a. So now we have the slope, the tangent line formula. This is the slope of the tangent line to the graph of f of x at x equal a. Okay. Right, so this is one form of the formula. We have another form. Okay, so again, let's go back to the original secant formula as that one, right? X1, x2, f of x1, f of x2. So it's the slope of the secant. Now this time, I want to replace, well, the x2 with a plus h. Now, let me explain a bit here. The p, the x1, okay, I still label it a as the fixed constant. Now the difference is instead of the q you call x, we call a plus h. So what that means is the distance between the horizontal between p and q, that distance is h. Right? If that is a, this distance h, then the x coordinate of this of the q will be a plus the distance is a plus h. Okay, so we plug in. Okay, let x1 be a and x2 be a plus h, where h is really the distance between x1 and x2. Okay, so again, that is an h. If you call this is a, then this is a plus h on this side. But a plus h give you the x2. And when you plug in, we got the formula f of a plus h minus f of a over a plus h minus a. Notice on the denominators, the a cancel out, and we left with just f of a plus h minus f of a over h. Again, you see that this formula is really the change. The top is really the change of y. Okay, the top is really the change of y, which is that vertical distance there is the numerator. Okay, so that is really f of a plus h there minus f of a. And you're gonna divide it by, you see this slope is rise over run. So the horizontal distance between P and Q is not just H. See that one here, right? So that is just another form of the same formula. And then of course, now we want to find the slope of the tangents. Then you want Q approach P. When Q approach P, notice that the distance between the horizontal distance between the P and Q getting smaller, right? So that means H gonna be smaller and smaller and smaller. So that leads to his animations that you can see. So it's a tangent line we need to find. That's a secant line we start with, say PQ, right? So here's an A, it's an A plus H. Now, if you let this approach, let it approach, getting closer and closer and closer and closer. Then notice that the Q is getting closer and closer to P, and then that means your H is going to be approach 0. So we let H approach 0, okay? Then the formula of slope of the tangent line now is limit of f of a plus h minus f of a over h, where h approach 0. Right, so that gives us the slope of the secant line, tangent line. Let me illustrate that with an example here. So let's say if I want to find the equation and equation of the tangent line to the function f of x at f of x equal x squared at x equal 3. Okay, at x equal 3. So what it means is, I mean, from the graph point of view, if you draw, hey, this is x and this is the y-axis, and you have the parabola, right? The parabola like this. Then we are looking at what the x equal 3, so be 1, 2, 3. So say it's here. Then we want to find the slope of the tangent line to the curve at this point. Right, so that's a tangent line. And of course, in order to find the slope of the tangent line, you need to use a formula we just have derived. Okay, so here's a 3, and don't forget that when x is 3, you plug in that's 9. So the point here is really 3 and 9. Okay, so what's missing is we need the slope of the tangent line. So now if you look back at the formula here, f slope tangent line is the limit of f of a. What is a? A is the x coordinate of the tangent points, so the p. So in this case, the a is 3. The a is 3. Okay. So look at the formula. This is what we have. The slope of the tangent lines is limit h approaches 0, f of a. Again, a is 3, so it'll be f of 3 plus h minus f of 3 over h. So you actually just need to do this limit. In the numerators, we have f of 3 plus h minus f of 3. So again, what is f of 3? F of x is x squared, so f of 3 is 3 squared, so that is 9. And what is f of 3 plus h? F of 3 plus h is 3 plus h squared. Okay, so you have 3 plus h squared. Well, we're gonna simplify this. Maybe on the side, if you square this 3 plus h times 3 plus h, we should have 9 plus 6h plus h squared after you forward this out. So f of 3 plus h is equivalent to 9 plus 6h plus h squared minus f of 3 is 9 and everything over h. Okay, so from here you see that the 9 and the 9 got canceled, and we have 2 terms left on the numerators. Each has h in common, so I can pull out an h and have 6 plus h over h, and h approaches 0. And then from here I can cancel out the h, and you can do direct substitutions when finding limit, and that is 0 plus 6 or 6 plus 0, that is 6. So now we have the slope of the tangent line at the point 39 here is 6. So what is the equation of the tangent line? We're going to use the point slope form y minus y1, which is y is 9, equal to slope 6 times x minus x1, which is 3. Solving for y, you should have y equal 6x, that's minus 18, and then plus 9. So be 6x minus 9, and this is our answer. Okay. Now, one thing you notice that in finding the slope of the tangent line, we're using this formula, right? So that one, and then we're going to find the limit by simplifying cancel common factor before we do the direct substitutions. Okay. Now, if we're going to want you to do it with x equal 4, so the same thing, like we're going to find the slope of the tangent line, but not at 3 now. This is at 4. I can see the slope actually steeper, and so the answer will be a bit different, right? The slope being the difference. So in this case, your slope at x equal 4, so the a is 4. So you can repeat the process here. The slope of the tangent line is limit, and instead of 3, you have 4 plus h minus f of 4 over h, where h approaches 0. And you should see that there's everything very similar, It's just a different number, 3 instead of 4. Now, instead of 4, you actually have 4 plus h squared here, right? So you should have 4 plus h squared here, and then minus f of 4, you plug 4 in, that's 4 squared, or 16 over h. And then from here, I can again just simplify. When you follow this out, that'll be 16 plus 8 times h plus h squared minus 16 all over h, and h approach 0. Okay, and then you can cancel the 16 minus 16. You're left with an h. We have a term on the top and the bottom, so I can take out an h here, and then we have a plus h over h, and h approaches 0 again. Then I can cancel the h, and can do the direct substitutions, and that a plus 0 or just 8. Okay. Then from there, I can find the equation in the line, the same thing. 3y minus y1. In this case, if x is 4, the y should be 16. So y minus 16 equal 8 times x minus 4. Or solving for y, you have 8x minus 32, and then plus 16. I think we have minus 16. Right, so that's the equation of the line. Now, as you can see, I can continue it on and on with the different point, right? If x is 5, and 6, and 7. So notice that every time you find the slope, the secant line, you need to apply this formula. Okay. Now, notice that from the formula that we have, right, this one here, f of a plus h minus f of a over h, the formula that we have. If you read the textbook, or maybe you look at the homework problem, you see that the formula is not exactly the same as this one over here. Okay, so it's not exactly the same. Now, the reason is the book doesn't use the letter H. I prefer letter H. the textbook actually used the delta x instead of an h. So you might see the formula as f of a plus delta x minus f of a over delta x instead. Okay. So again, the delta x is just the horizontal distance. We often use this one to denote a very small distance. In fact, it's really small. So either delta x or h is fine. So make sure that you see this is the same thing. If you're comfortable with h, you can deal with h, and then you can switch back to the x1, just the same. Okay. Now, if I go back to this one here. Here's another thing that you can actually do in the calculators, right? So if you want to check the slope of the tangent line using the graphing calculators, you can go to the graphing calculator TID3 and you're gonna go to graph first, okay? So what you can do is can graph, let's say graph y equal x squared, you enter the formula. And then once you're done graphing, you go to the calc menu. The calc menu, it should be the top, I think the top 5, 6 buttons. Go to the calc menus, and then in the calc menu, I think there's 1 through 7, I believe there's 6 or 7 options. And then you pick the one, I think it's 6, the one that says dy/dx. That means the derivative or the slope. Then once you choose that option for dy dx, you'll be prompted to enter x equals something, right? So if you say you enter x equals 3, and that will spit out the answer as 6 at the slope of the tangent line that we just found in the previous example. Okay. Now, you can see that the example that we have, we are dealing with that limits of the difference quotient. This is called the difference quotient. We do that again and again and again and again, right? So that formula right here. So we're gonna give this a special name, and it'll replace the a back as its constant to any variable x. So we call that the derivative. So basically the same formula, but we now define the derivative of f of x denoted f prime. So that's kind of apostrophe e. F prime of x will be limit of. You see that's the same, but I change that to an x. So that will basically turn that into a function rather than a values. Okay. So if the limit exists, and this is called the derivative of the functions. So every time you ask to find the derivative of the functions, and that's what you would do. Okay, take the limit, and this is called the difference quotients. Okay, now notice that the derivatives not always exist, because when the derivative defined by the limit, and as we know, limit may and may not exist. If the limit exists, or if the derivative actually defined, then we say the function is differentiable at the point A. Okay. Now, from the definitions and example that we did, notice that the derivative, what does that formula represent? Well, don't forget that this will represent the slope of the tangent line at x. Okay. So if f is functions, then f prime of x is a new function that represents 1, the slope of the tangent line to the graph of f at x. Okay, it just, again, the slope of the tangent line, we define it in terms of x, so it is the slope of the tangent line. 2, in general, that represents the instantaneous rate of change of f of x with respect to x. Okay, so I said instantaneous rate of change. So that means if f of x is a function, remember, when it's a function, the function could represent anything, right? So when you have the function go like this, now let's say if this is t, or x is time, and then if f of x, if the function, let's say, is populations, then the slope of the tangent line at this point is, so let's say 2010, say, then if this is the growth of the populations, then the slope of the tangent there, when they measure the rate of change of f of x, that really measure the change of the populations at the year 2010. Okay, again, that's rate of change. So the change of population with respect to time at that particular moment. Now, if that doesn't represent population, it could represent money, the growth of bank accounts. It could represent the growth of the bacteria. It could represent, if this is distance, right? So this is the object is moving, and it's a distant travel, and then this is what that's going to be the, if you're looking at the derivative, so that is the change of distance with respect to time. So change of distance with respect to time is really the velocity of the moving object. So it has another meaning. That means the velocity of an object at time x, if f of x is the positions or the distance functions of a moving object. Okay. Now, how to find the derivative of the functions in general? So I'm going to do one quickly. Remember the definitions here. F of x is x squared minus 3x, right? So what is the derivative? Okay, the derivative at perm of x by definition is limit f of x plus h minus f of x over h, where h approaches 0. So notice that this time we have f of x plus h minus f of x. So f of x plus h, so what is f of x plus h? So don't forget the function notation. If f of x is x squared minus 3x, then f of x plus h is x plus h squared minus 3 times x plus h. Right? You're replacing x with x plus h. You got this formula there. Now from here, you can actually apply the formula now. F of x plus h, let's skip the step there. You might want to simplify this part first. That is what you FOIL that out. It's x squared plus 2xh plus h squared distributed in minus 3x minus 3h. So on the numerators, this quantity is just that, right? And then you minus f of x. So I think I don't have the detail here. Let's simplify it from there already, actually. Yeah, so the numerators, right? If you take this quantity is f of x plus h, you subtract f of x. F of x is x squared minus 3x. So you notice that when you subtract, you can cancel the x squared minus x squared cancel, right? And then you get negative 3x minus negative 3x, they got canceled. So what you have left is this term, and this term. So here I have, see this quantity right here. After simplify, you have 2xh left plus h squared minus 3h over h. Okay, so simplify to that term, and then you factor out the h, cancel out the h, you got 2x and h left and minus 3 when the h got canceled. So now you got this. Now the derivative is the limit of this quantity. So that's a limit of this quantity right here. Okay, so limit of this quantity where h approaches 0, but if h approaches 0, you can do direct substitutions, and the answer is 2x minus 3. Okay, so from the original function is f x equal x squared minus 3x, and now the derivative that we just found is 2x minus 3. Again, don't forget that the derivative represents the instantaneous rate of change of the function with respect to x. Okay, let's say you want to find the slope of the tangent line. Slope of tangent is was an s, but if I add the question, what is slope of the tangent line at x equal 2? Well, all you do is just plug 2 in, right? So now the slope is really 2 times 2 minus 3, and then you got 1. Okay, when you find the slope of the tangent line, how about at x equals 0? Then the slope is 2 times 0 minus 3, so that's negative 3. The slope is negative 3. Again, the derivative gives you the slope of the tangent line at x. So that's where you see, once you've done the derivative, you find the slope quickly without going through that process. Again, this process called the limit process. You're using a limit or the 4-step limit process to find the derivative of the functions, right? So the rest of things that you read, basically, it's not so important. Right. So I'm going to stop right here.